Welcome to Section 9, Lesson 7. Rational expressions show up in three classic application families: work problems, distance, rate, time problems with a current or wind, and mixture problems. All three reduce to a rational equation that we solve with the techniques from Lesson 5. Work problems: when two people work together, their rates add. If one finishes alone in A hours and the other in B hours, the combined rate is 1 over A plus 1 over B jobs per hour. The time together is the reciprocal of that sum. Distance, rate, and time problems with a current or wind use the relationship distance equals rate times time. The unknown is usually the current speed. One equation captures both directions because the distance is the same. Mixture and dilution problems express the salt or solute amount as concentration times total volume. The conservation law is salt before equals salt after, plus or minus any added or removed material. If A finishes a job alone in 4 hours and B in 6 hours, how long does it take them to do it together? The bar chart on the right shows what happens with rates. A's rate is 1/4 of the job per hour. B's rate is 1/6 of the job per hour. Working together, the rates simply add. The combined rate is 1/4 plus 1/6, which equals 5/12 of the job per hour. The bars stack visually. A's bar plus B's bar reaches the height of the combined bar. The shorter time wins more height, so A's bar is taller than B's because A is the faster worker. Time together is the reciprocal of the combined rate. 1 divided by 5/12 equals 12/5, which equals 2.4 hours or 2 hours and 24 minutes. Always faster than either alone. A boat travels 12 miles per hour in still water. It takes 3 hours to go upstream and 2 hours to come back the same distance. Find the speed of the current. Let C be the current speed. Going upstream, the effective speed is 12 minus C. Going downstream, the effective speed is 12 plus C. Distance equals rate times time, and the upstream and downstream distances are equal. 3 times 12 minus C equals 2 times 12 plus C. Distribute and solve. 36 minus 3C equals 20. 4 plus 2C. Move terms. 12 equals 5C. Therefore, C equals 2.4 miles per hour. The graph shows the upstream and downstream distance functions. They intersect at C equal to 2.4. The current flows at 2.4 miles per hour. The total distance traveled in each direction is 28.8 miles. Both lines pass through the same height at C equals 2.4, exactly as expected when the distances are equal. A 50-liter tank holds a 30% saline solution. We want to dilute it to a 20% solution by adding pure water. How much water must we add? The salt amount stays constant. Initially, 50 liters times 30% equals 15 liters of salt. Adding X liters of pure water makes the total volume 50 plus X, but the salt is still 15 liters. The new concentration is 15 divided by 50 plus X, and we want that to equal 0.20. Solve the rational equation. Multiply both sides by 50 plus X. 15 equals 0.2 times 50 plus X. Distribute a 15 equals 10 plus 0.2X. Subtract 10 and divide by 0.2X equals 25. Add 25 liters of water. The graph shows the new concentration as a hyperbola dropping from 30% toward 0 as X grows. The horizontal target line at 20% crosses the curve exactly at X equals 25, confirming the answer geometrically. 3 takeaways for rational expression application problems. They cover the 3 most common families on standardized tests and homework. Work problems combine individual rates by addition. If person A finishes in A hours and person B in B hours, the combined rate is 1 over A plus 1 over B. The time together is the reciprocal of that combined rate. The setup is mechanical once you remember rates add but times do not. Distance, rate, time problems with a current or wind use distance equals rate times time twice, once for each direction. The unknown current speed appears in both effective rate expressions, and the equation that ties them together is the equality of the two distances. Mixture and dilution problems track the amount of salt or solute, not the percentage directly. Salt amount equals concentration times total volume. Conservation of salt under added pure water gives the rational equation, and the solution lands at the intersection of two simple curves on the graph.